In this context, optimize means minimizing the amount of work and situations where layout and graphics need to be rebuilt. So, in the UI system, we have a concept of a canvas element, and all of our C# components that live on a canvas inherit from this. They implement an interface called iCanvasElement, which provides a number of methods. The most important one in this situation is rebuild. Now, what the rebuild interface does is it receives callback from the canvas rendering system whenever a canvas is about to be rendered. It receives a number of events, such as the 3 layout events, those being pre-layout, layout, and post-layout, as well as 2 renderer events that occur just before rendering happens. When you receive these callbacks, you can modify the status of the canvas renderer. So for example, the pre-layout calculation is normally used to perform calculations that the layout step uses. Layout is used for positioning elements and is extensively used by our automatic layout system. And the post-layout step is for updating any data that is dependent on the layout. When it comes to rendering, there are 2 callbacks. The pre-render, which you can use to update your vertices and materials, and your late pre-render. And you can use this to update any data that is dependent on vertex generation already having occurred. We use this, for example, in our input field to position where the blinking caret appears. This is because we need the text element to have already generated the vertex locations. So these callbacks don't arrive every frame when a canvas is being rendered. You need to register your elements to receive them, and this is so the work doesn't happen more than it needs to. If you are doing some layout calculations, there's a callback you can use. This exists on a static class we have called the Canvas Update Registry. What you can do is if layout has been modified, you can register your canvas element for layout rebuild, and if you do this, your element will receive the layout callbacks. Similarly, if you modify a texture or some vertices and wish to have them update a canvas renderer, you can register your canvas element for graphic rebuild, and then you will receive the 2 rendering commands. So one thing to note is that rebuilds are deferred and are not called immediately. Take, for example, a graphic you have in your scene. If you modify the material and the texture and the vertices, if we did this immediately, there would be 3 very heavy internal calls issued to the canvas renderer. What instead happens is we defer these calls till the very end, so this calculation only happens to happen once. What this means is you can have multiple things trigger the same rebuild, but internally, we only issue the calculation once. From Unity 5.2, this callback happens just after late update. So you can modify any data on your canvas and know that late update has already been called. Prior to Unity 5.2, this call would happen when just prior to the canvas being rendered. This would either be after onGUI, if you had an overlay canvas, or it would be during the rendering loop if you had a world space canvas. So what kind of things should trigger which type of rebuilds? What we want is to only have rebuilds happen when they're needed. This is because if we do it too much, we waste calculations on the CPU, whereas if we do it too little, we'll have buggy or non-desired behavior. So the first thing is when property changes occur in your components. If a property change may require changes to vertices or materials or textures, essentially anything on Canvas renderer, you want to register canvas element for graphic rebuild. This will allow you to receive the callbacks that you can then use to update the Canvas renderer. If a property you modify changes anything associated with a rect transform, such as the position or size, if it's something simple, you can just modify the rect transform directly. An example of this is if you have a slider and you've modified the value on the slider, you may want to just move the knob position. If you are using the auto layout system, you can use the higher level API, which exists on the layout rebuilder, which is mark layout element for rebuild. Whereas if you're writing your own layout system and completely ignoring the Unity auto layout system, you can just register your Canvas element for layout rebuild. In addition to modifying a property and manually registering your element, Unity will also issue some callbacks to your components if something has changed. So for example, if the rect transform dimensions have been modified, you'll get a callback for this, and you may want to mark your graphic for rebuild at that stage. If the transform parent has changed, you may want to do some new layout calculations. Or if you're a part of a Canvas group and it's modified, you may want to update the internal state of your element. So here we have, we've quickly described what to do if you're writing your own elements for the UI system from scratch. But we actually provide some shortcuts. So in the UI system, we have a number of base classes that you can inherit from, such as graphic, selectable, and layout group. And what these do is provide much of the foundation work that you may need to want in your components. If you extend from these, much of this work will already be done for you. So where do you go to get more information about this? The first thing is, if you're interested in learning more about the Unity Frame Debugger or the Unity Sprite Packer, that's extensively documented in the Unity documentation. So search for those in your favorite search engine. If you wish to actually look at the Unity UI source code and see how we've done things for our custom buttons and custom components, we have that available on an open source repository. And if you search for Unity UI Bitbucket, you should get access to all of the source code. So today we've gone through a number of steps for optimizing your UIs, both from a content perspective as well as from a code perspective. We hope that you can use this information provided to increase the performance of your UIs and learn more about and create some amazing things. Thank you. And there's time for questions as well. Yes? Mm-hmm. So for the UI system, if you follow the optimization steps, you saw that we could reduce the draw calls down to 2. If you write some code to put your textures into an atlas as well, then that can be 1 draw call. But we don't put our text by default into an atlas, and we don't have support for that currently. It's something we look to work on soon. No, they can share the same material, but they still have a separate texture. So it's still going to be an extra draw call.
You also talked about how certain changes to CPU load. So I'm just curious to know for the UI, how does the load differ between the CPU versus the?
So the question was, where is the CPU work and where is the GPU work with the UI? So I'll talk about what's coming in 5.2 because that's the future state. So what we have happening is the CPU side does things like on the C#, you'll calculate where your vertices are, what color your vertices have, and things like this. And this is in the graphic layer. What happens is that data is then passed to C++, and the batching happens. The batching happens in C++, and in 5.2, that actually happens on a background thread. So it's all parallelized from the main work. And then that data that is generated is passed to the GPU for rendering. So essentially, all of the GPU is only doing as few render calls as possible because of the batching, whereas the CPU has to do work to combine these elements you input into a batch.
Hi. I have a question about the rect that is used for considering input. Right now it's used square. I was wondering if it's possible to use a irregular shape for input.
Yes, so what happens in the UI system is this is essentially for raycasting and areas you can click. Yep. So at the moment, we're looking at the rect directly. We're not looking at, say, the image or whatever is in there and looking at the alpha. There's two reasons for this. The first is that looking at the image is essentially a per pixel operation and becomes quite slow. And the second is, to do this, you need to keep a copy of the image in main memory. You can't just upload it to the GPU and discard the main memory version, which is what, by default, things do in Unity. What we have in the image is, if you look at the source code that we have available on Bitbucket, there's some prototype code in there that is disabled by default for allowing this functionality that you want. What you can do is there's a virtual function, and you can override like the raycasting data and then do per pixel raycasting against any image you have. So you can do this, it's just we don't support it out of the box.
It's actually using raycasting internally.
Not
the real physics engine.
Not physics raycasting, no. It's using a custom screen point to ray intersecting with rect's raycasting.
So even though the functionality is disabled, by implementing the virtual function, you can implement a specialized version.
What it allows you to do is filter the raycast result, so you can say, by default, it says yes, and what you can do is you can say, let's look at it at a sub-element level, and then discard if you click on an area with 0 alpha, or however you wish to implement it.
It would be nice to have some sort of like primitive type 2D shapes that we can like compose some.
Yeah, I mean, I think one of the plans for the future will be to start looking at things like the sprite polygon colliders and that kind of stuff for this kind of thing, but we're not there yet.
The 2D team showed a very nice demo where there was a masking feature. Think of it like a looking glass being moved over a mesh and it making only that part transparent and showing a mesh which was behind.
Yep, you can already do that in Unity 4.6. The UI system supports masking.
Okay.
Hi, what's the best way to support multiple scene when doing UI? Like in our case, we have, because for each canvas, you need one camera. So we work with multiple scenes. So like in us, for example, there's a certain panel, and then it has a camera and a layer, and then in another scene, there's a separate camera and another layer. So there are only 32 layers available, so we want to reduce like the layers used. So how do you go about that?
So if you have a look at the canvas, you'll see that there's a thing here called override sorting. So what I would do in your situation is I would have all of the canvases be rendered by the one camera, except I would just specify which sorting layer you wanted each canvas to be on, so you could render them back to front.
Okay, and then that's already, it doesn't matter which camera?
It doesn't matter which camera, no.
Okay.
So one of the optimizations that you suggest with regards to making the element, the UI elements coplanar to the canvas. What if we are working with a virtual reality type application where we actually want to take advantage of having the items in different planes or so? So are there any alternative strategies for that or so?
Well, so the advice, just to be clear, that I gave for that point was that it's not don't do that, it's just be aware of what you're doing and how your content is created. In your situation, I would use extensive use of texture atlasing, as well as try and use the same material as much as possible. The only issue with this is currently, if you have text, because we don't put it in the same texture, it will break. And that's one thing we want to address, especially for situations like yours. But yeah, just be aware of these limitations that we currently have.
Yeah. I was also thinking about input on moving buttons, because I believe the way it works at the moment is if I move the pointer on top of a button, it detects the mouse over. But if I'm just have the pointer standing there and I move the button below the cursor, it doesn't really detect the input. I'm guessing that's it's only checking when the mouse is moving.
Yep.
I was wondering.
That's a bug that I think we've fixed for 5.1. So yeah, I fixed that bug, and I'm not sure which release it's going in off the top of my head, but
Okay.
it might have even been patched into 5 by now.
Cool. Yeah, I thought it was some optimization, but if that was the case, it could be exposed as an option.
Oh, no.
Like,
we were always looking at the button moving, we just made a mistake.
okay, great.
Are there any other questions at all? Yes, we have one.
Hello. Can we make let's say if I have a player game object and I want a text or a health bar above his head, can we use a canvas?
Yes, you can. I would recommend using a world space canvas and positioning it above the character's head.
Okay. Thank you.
At the front.
A very different question, not exactly related to UI, but sorry for asking this. Does Unity or UI system support any sort of data binding?
Yep. So we have on our roadmap for the future a data binding layer, but the main development work we're doing right now is essentially improving the internals and the core of the system so that we have something we can work on for the next, say, 5 to 10 years and keep really solid. So we don't have a data binding layer yet, but it's on our roadmap for the future once we stabilize the core of the UI.
So can you recommend a good design pattern for input? For example, I'll give you a relevant example. Let's say we have a slider value. Either the same slider value could be increased by the up-down key on the keyboard, or on the UI, you could take the knob and take it up and down. So as of now, all of them refer to, let's say, an internal float value. But you need to then write a good amount of code to see what has changed, what is the master which is controlling the value, and then update. Any thought on a good design pattern?
So are you talking about, so at the moment what we provide is when a value changes, for example, we issue a callback, such as on click. Are you talking about working the other way, such as when a float value changes, updating the slider?
Yes.
Yes. So there is a data binding layer that exists for the UI system on the asset store currently. It's meant to be quite decent from what I've heard, but I haven't used it myself, and we'll be going in that direction.
What is it? What's the asset?
Don't know its name off the top of my head, I'm sorry. I just watched a video on how it worked and I thought it was quite impressive.
Yeah, so based on what you were recommending about like every time we change the hierarchy, there are some calculations that take place. Say for dynamic data, if I wanted to populate a list with dynamic elements and I don't know the amount, would you suggest to create them all in the same frame or scatter around in different frames, or what's your suggested approach to?
Yes. So my suggested approach for this, I'm guessing you want to put these in some kind of scrollable list, for example.
Yes.
Yes. I would make a list that had just as many elements for display, plus one element above and one element below. And as I moved the list, I would essentially just repopulate the elements and not have everything together.
Right. Like,
so you would basically pool these things and reuse them without recreating them every frame.
So am I right in assuming, just like you have the on-click which gets called and you can link it with the function over here, similarly, remotely, you can monitor this as an event using delegates?
Yes, so you can register, so this internally is implemented as a delegate, and you can register against this. So the button script has like a public listener or delegate you can register against from code if you don't want to do it from the UI.
So on the button, you have on-click. Similarly, on sliders, and could you just list out a couple of methods or events that you have?
Yeah, so let's have a look. So slider, for example, has an on-value changed. I won't go through them all now, but anything you would expect to have one does. And toggle has an on-value changed as well, I believe. Yes, that takes a boolean. Okay, and apparently the documentation has a full list, and I think I wrote that, so I should know. Okay. Are there any other questions? Thank you.